Okay, now, basically, you know, I really need to run the whole idea of basic function graphs by you because, you know, a basic graph, let's just say, well, let's say z versus y, okay? The y equals x squared graph, or write y equals x squared, because that's, of course, what we're doing in pre-calculus. Z equals y squared, right? If y is 0, z is 0. If y is 1, z is 1. If y is negative 1, z is 1, right? If y is 2, z is 4. And if y is negative 2, z is negative 4, so we get this shape. Okay? So, that would be our graph. That looks just like this one, but of course I've got a different z scale. This is if z equals 1, right? I'm sorry, if it's z equals y squared, then z is 1 at this point, okay? Now, if it's 9y squared, then z is 9 at this point, okay? So we have to kind of automatically know that y squared gives us a parabolic graph, okay? Or x squared, or whatever. And that has to be pretty much automatic. We don't want to have to stop and think about that. One reason is, talk about conic sections. An ellipse is one conic section. A hyperbola is another one. We'll get to that in a minute, but you use the same picture, but you use it a little differently. You use the same rectangle to do a hyperbola. That's what happens if you have a minus on one of these and a plus on the other. You still use the same picture, but the graph looks much different. The other conic section is the parabola, and that's what this is. So there's a kind of a basic parabola. So when we talk about conic sections, we're going to make sure we understand this, okay? Okay, so, okay. In any case, in the YZ plane, you get this, right? Well, that means that in the YZ plane, your graph is going to look like this, okay? And it's going to continue getting steeper as it goes on up to this. Now, it's not drawn very well, okay? But it's a parabola here, okay? Similarly, well, show me what you have in the XZ plane. And I say the YZ plane because I'm used to saying Y. It should be, well, the YZ trace is okay, but it's the ZY plane, Z versus Y. Show me the Z versus X trace. Same idea, but adapted. And what you're then going to get is you're going to get a picture of the graph here in the X, you know, above and below the X-axis.